Example 4. Find the real zeros of the following polynomial function f, and then we'll use the real zeros to factor. Okay, so if you remember our steps from before, our first step is to look at the degree, because we know the degree will tell us the maximum number of real zeros that we're actually looking for here. So we know we have a degree 4 polynomial, so we have a max of 4 real zeros. Step 2, we're going to do the rational zeros theorem. So remember, that's the P over Q. It's going to give us a list of possible rational zeros of this function. So we'll first list P, which remember is factors of the constant. So we want to look at the 8. We want factors of 8. So we'll put 1 plus or minus symbol out in the front, and then list all the factors of 8. So 1, 2, 4, and 8. And then we want to list Q values. So remember, Q is factors of the leading coefficient. Well, we don't have any coefficient in the front there, so we know that that's a 1. So we just need to list factors of 1, which is obviously just plus and minus 1. So then your possible rational zeros are all the possible P over Q combinations. Well, if Q is just 1, it's just 1 over 1, 2 over 1, 4 over 1, 8 over 1. So that's just plus or minus 1, 2, 4, or 8. So these are our possible rational zeros. So it could turn out that none of these are actually the zeros, but if it has rational zeros, it would occur on this list. So again, for example, 7 could not be one of the real zeros of this function because it doesn't appear on this list. Okay, step 3, we're going to graph on the calculator. So we enter our function here, x to the 4th minus x cubed minus 6x squared plus 4x plus 8. And if I just graph on a standard viewing window, zoom standard, so we know if we're looking for real zeros, we're looking for x-intercepts. So we can see here it appears to have 3 x-intercepts. And we could verify these. It certainly looks like we have a 0 at -2, -1, and +2. So we could verify in the table. So if we scroll back here to -2, I do see -2, 0. There's -1, 0. And there's 2, 0. We could also calculate the zeros. We could also do second trace and calculate the zeros as another option. But the idea is that we see 3 x-intercepts, and we know we could have up to 4 real zeros, and also notice that at this x-intercept, at 2, it touches and comes back up, it doesn't cross. So that indicates that we have even multiplicity, which makes sense here because we've got a total of degree 4, but we only see 3 x-intercepts. So let's make a little sketch of this in our notes here. So all that's important is those x-intercepts and the general shape. We don't care about anything else. So we've got -2, 0, -1, 0, and 2, 0. And we've got this kind of W-looking shape. So we know the answer to this problem already. It's asking us to find the real zeros. The real zeros are our x-intercepts. So we see 1, 2, 3, -2, -1, and 2. So those are the real zeros. So our real zeros are x-intercepts. So we know in this case that's -2, -1, and 2. But we have to now verify this algebraically, kind of pretend we didn't have the graphing calculator, and verify this algebraically. Sorry. Okay, so step 4. If we want to verify, and we'll just pick one of them, we have 3 zeros to verify. Pick any of them to start with. I'll start with -2. If I want to show that -2 is a real zero, I could also show that by dividing by the corresponding factor. So if I want to divide by the factor x plus 2, I'll use synthetic division and put the -2 in the upper left corner. And now I'll list my coefficients of the dividend. So I'm dividing by x plus 2. So if I show that by dividing by x plus 2, I get a remainder of 0, that just verified then that negative 2 is a 0 of that polynomial. And what's useful about the synthetic division is that you're testing, the 0 that you're testing goes in the upper left corner. So that r value, x minus r, that is actually the 0 that you're testing. So we'll do our synthetic division, bring down our 1, multiply 1 times negative 2, get negative 2, add down the column, negative 1 plus negative 2 is negative 3, multiply, negative 3 times negative 2 is 6, add down the column, negative 6 plus 6 is 0, 0 times negative 2 is 0, add down the column, 4 plus 0 is 4, 4 times negative 2 is negative 8, add down the column, and we get 0. So we do get that remainder of 0, which we know. We know we're going to get a remainder of 0 because we saw on the graph that negative 2 is one of the x-intercepts. So now, part of what we're being asked to do is not just find the real zeros, but to use the real zeros to factor f. So we're going to break down our polynomial function f. We just divided by x plus 2 here. So I can now rewrite f of x as the product of x plus 2, and here is our quotient, x cubed minus 3x squared plus 0x, we don't have to put the x on there, plus 4. So you're breaking down, we started with our polynomial function f, a degree 4. We broke it down into the product of these two factors. So now let's continue again. So this just verified that negative 2 is a 0. Well, we've got two more zeros to verify. We've got negative 1 and 2. Let's look at the negative 1 next. So now I'm going to divide the depressed polynomial, the answer from the synthetic division, I'm going to divide it by x plus 1 in order to show a remainder of 0, which will verify that x plus 1, or that negative 1 is a 0. So now notice, when we're doing our synthetic division here, we're not going back to the original. We're breaking it down. We're using the depressed polynomial because we know that if x plus 1 is a factor of this, that means it's also a factor of the original dividend. So I'm going to list my coefficients 1, negative 3, 0, and 4. So again, I'm not going back to the original. I'm breaking it down. So I bring down the first term, bring down the 1, 1 times negative 1, negative 1, add down the column, negative 3 and negative 1 is negative 4. Negative 4 times negative 1 is 4. Add down the column. 0 plus 4 is 4. 4 times negative 1, negative 4. Add down the column, and we get 0. So again, we get a remainder of 0 when we divide by x plus 1. So we just verified here algebraically that negative 1 is a real 0 of this polynomial. Now we just have one more 0 to verify. Now let's continue our factoring, breaking this down. So up here, we broke it down into x plus 2 times x cubed minus 3x squared plus 4. So I'll bring down my x plus 2. But now we just broke down x cubed minus 3x plus 4 into the product of x plus 1. And now our depressed polynomial, our answer, our quotient to this division, x squared minus 4x plus 4. So now, once we're down to a quadratic depressed polynomial, once we do synthetic division and break it down into a quadratic, we don't need synthetic division anymore. We can just try to factor or use quadratic formula if we have to. So let's see if we can factor this, and this does factor. So I'll bring down my x plus 2, x plus 1, and now we can see that this is going to factor into x minus 2 squared. So this just verified, if we see that x minus 2 is a factor of f, then that means that 2 is one of the real zeros, which we saw graphically on the calculator. So part of our answer here, here's the factorization. We use the real zeros to factor. And then we just showed algebraically that our real zeros are what we thought they were from the graph, negative 2, negative 1, and 2. So you can see that this is a degree 4 polynomial. It only has 3 real zeros. Remember, it could have a max of 4, so it has 3. And you can think of it as this factor, x minus 2, because it's squared, it's kind of like counting that 0, the 2, it's like counting it twice. So it counts twice, and that gives you a total of degree 4. These are each degree 1. This is degree 1, but it's squared, and it gives you that degree 4.